Hello friends, today we are going to talk about class template argument deduction. This is a feature that exists since C++17, so if you're planning on using it in your code base, make sure you have C++17 support. In this video, we will dive into a couple of examples and see how class template argument deduction can make our code easier and less verbose. Okay, without any further ado, let's dive into it. Alright, so let's write a really simple program that creates a vector and prints its value to the output, right? So let's create a vector of ints. Let's call it vec. Let's give it a bunch of random values and let's simply print this to the output, right? And one way to do it is you can use const auto ref and print it out. Let's run this. Hopefully we should see 1, 2, 3, 4. Now before C++17, right, you had to specify the type of your argument in the template, right? Because standard vector is a templated class and it can take in any types here, right? Maybe primitives, maybe user defined, doesn't matter. With C++17 and using class template argument deduction, this is no longer required. So you can simply remove the templated part and the compiler will happily compile and run the code, right? Isn't that cool? So let's try this. There you go, right? Now what's happening here, right? The compiler will cleverly look at the arguments provided in the constructor and automatically deduce the template parameters, right? Now there are some deduction rules that the compiler applies and sometimes it can get confused, right? And when trying to deduce the types, but there is a solution for that and we'll look into that later. Let's do one more thing here, right? Let's try to prove that the compiler actually deduced the correct type of the argument, right? So let's add some more information here. Type of v is, and we can use the type id operator to get the type of an object, right? And the way you do that is use type id, give it the object, and then I think use the name function on it to get the type, right? Let's run this and see what we see. Let's add a space here and we see that type of one is I. Now the reason why you're seeing an I here is because that's the mangled name produced by the C++ compiler. So each type has its own letter, right? So we see I for ints, and for just for experimentation, if I change this, let's say to all be doubles, you will see we see a D in the output, right? Type of this is D. We can also try floats just for experimentation sake and see if they, right? Okay, we see Fs. So looks like the compiler is doing its job and reducing the right types, even though we don't specify the templated argument for this vector, which is good. One more concept you need to be aware of is deduction guides. Deduction guides can be implicit or explicit, meaning if you don't provide a deduction guide, the compiler deduces template arguments directly from the constructor's parameter types. But if you do provide a custom guide, then it asks the compiler to override the default behavior. So basically think of deduction guides as rules that you are specifying, that you have to specify in order for the compiler to behave differently, right? Let's look at an example so that it's more clearer, right? I have a really simple class here called person. It's templated. It has a constructor that takes in an argument and saves it off in a member here called name, m underscore name, which is private. It exposes a function called print, and if you look closely, all it does is it's printing the type of this member here, right, which is m underscore name. And as we saw earlier, type ID can come in really handy when you want to know the type of your objects. So in main here, I created the person object, provided an argument in its constructor, and I called print on it, right? Let's check out the behavior. So type of div is PKC. Now what is PKC? PKC stands for pointer to a constant character, right? This is something that the compiler generates. It's called mangled naming. You can look it up. Every primitive type, or even user defined, right, has this naming that gets generated by the compiler. So in this case, our type is a const char pointer. Now this is where deduction guides can come in really handy. Now let's say the developer wants more control over the way the templated arguments are deducted here, right? What he can do is specify a custom deduction rule which will be used by the compiler. So right now the compiler is looking at this argument as a const char pointer, right? Let's say the developer does not like that. So what he can do is he can provide a custom deduction rule, and the syntax looks like this: const char pointer, and he wants it to look like, let's say, a standard string, right? Now if we run this, you will see that type of div is now a string, right? Which means he, by providing this custom guide, the compiler was basically forced to look at the constructor argument as a standard string instead of a const char pointer, right? So deduction guides basically handle cases where you need finer control over the template argument deduction. This is just something that you need to be aware of when you're using class template argument deduction. Alright, so let's wrap it up by having some final thoughts on class template argument deduction. So what it basically, this feature is all about allowing the compiler to automatically deduce template arguments from the type of constructor arguments. Deduction types or rules provide the developer with more control over how the arguments are deducted. So there are two ways: implicit and user defined types. And if you ask me what are the benefits of class template argument deduction, I would say, hey, it makes the code easier, less redundant, helps reducing a lot of boilerplate code that you generally have to write when you're working with templates, right? It also works great with standard library templates like vector, pair, tuple, etc., right? So I hope you guys enjoyed this video, and if you have some feedback for me, please don't hesitate to post it in the comment section. Thank you.